Probability is the mathematics of chance, and to find probability is to try to find about something we have no idea about. A formal definition could be written as probability, the mathematics of chance. This is expressed as a numeric value. What we try to do here, we express something that is random. We have no idea what that is, and we try to give it a numeric value so that we are able to understand it better. It is usually expressed as a percent. Percent means out of 100. Per means by, cent means 100. Expressed as a percentage. It is easier to understand a number in percentage. When we want to find the probability, the definition can be written as probability of an event is the number of times the event can occur and the total number of outcomes that are possible. So when we write this, number of times a particular outcome, which we call an event, can occur divided by the total number of possible outcomes. They have to be equally likely. Possible outcomes. An example would be, if there is a die throwing and we want to know, there's a dice game and we want to know what is the probability of getting a particular number. So if this is a dice, so we have a 1 here, we have a 2 here, 1, 2, 3 here, and we want to know what happens if you want to get a 2. First of all, let's see what is the total number of possible outcomes. We can get a 1, we can get a 2, we can get a 3, we can get a 4, we can get a 5, or we can get a 6. So probability of getting a 2 would be, the total number of outcomes is 6 and we want a 2. There is exactly one of these. The probability of getting a 2 is 1 over 6. As a matter of fact, the probability of getting a 3 is also 1 over 6. The probability of getting a 4 is also 1 over 6. As a matter of fact, the probability of getting any one of these is 1 over 6. If you want to find the probability of getting an even number, then we can see that not only 2 but 4 and 6, all these three numbers are even numbers. An even number is a number that can be divided by 2 and we get an integer when we do that. So there are 3 such numbers. So 3 divided by 6. I will try to leave the number as they are so that it can be seen what was the original numbers. Of course we can cancel it out and write 1 by 2, but I'm going to leave it like this. This means if this is done 6 times, in one of the cases we are going to get a 2. This means if we do it 6 times, in 3 of the cases we will be getting an even number. When we want to find the probability of something, this is how we try to figure out what might happen if an event we have no idea about, no way of predicting it. So we write a mathematical number. Now I said it is usually expressed as a percent because we don't intuitively have a clear idea of what a fraction is. For that reason, if we see a percentage, it is easier for us to understand what is actually going on. We might not know what 1 by 6 is, but when we see this is about 17%, we feel that 17%, not that high, not a good chance. This is 50%, so this has more chance. So the fact that we don't have a clear sense of fraction, a clear intuitive sense of fraction, we understand percentages better. For that reason, it is helpful if you just see what it looks in percentages. A percentage is nothing but a number compared to 100. 17% means 7 divided by 100. Percent divided by 100. Now, a little background. When we talk about probability, there is actually two types of probability concept. One is called the frequentist concept. Frequentist probability. And the other is the Bayesian probability. Bayesian probability is a probability of belief. What do you feel is correct? What do you believe is correct? That's not what we are doing now. When we say probability, we are always talking about the frequentist probability. This is a bit higher sense of probability, and it is used for other purposes, of course, important purposes. But whenever we are talking about basic school probability, the concept of probability, we are talking about the frequentist probability. In the frequentist probability, we need to actually do an activity to figure out what the probability is. It is not about what you feel is right, because what you feel is right might be wrong. So in frequentist probability, the one that we are doing is you have to collect the data and find out what the probability is. In order to do that, you need to have a sense of what is it that we do not know. What we do not know, something that we call random. If something is random, we do not know what it is. So probability is about uncertainty. If we know it, then it is not probability. That is certainty. That is determinism. We already know that. Random. If something is random, what does it mean if something is random? You might feel that you know what random is, but random is something that what nature does. If you flip a coin, you might feel, okay, I can make up something. Suppose I tell you, write down something. If coin is tossed 10 times, write down what would the outcome be, and you write something like this. You write head, tail, head, tail. You feel you're just making up random. What could be random? What you think is random? Head, tail, or head, or tail, or tail, or head, or something like. You just make it up. But in reality, if actually someone tosses the coin and they write it down, and if you see that and another person just makes it up in their head and just write it down, can you know the difference by looking at the two pieces of paper? The one where someone just wrote it down, what they felt like it, what they feel is random, and another person actually tossed the coin and wrote down the outcome. Would you be able to figure that out? Well, you'll be surprised what random that happens in nature is compared to what we feel is random, because this often happens. Head, 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 then a tail, or a head. This can happen. When someone is asked to write it out by themselves as what they feel is random, they usually do not write more than 2 heads or 2 tails, because they feel, no, that will not be random. But in reality, this often happens, that there are many heads, one following the other. So what you think is random might be completely different of what actually is random. Another example could be if someone is asked to just put dots on a paper randomly, what they feel is random, and they might just give the dots like this. They feel this is random. But in reality, if you just see a computer to do it randomly, where the computer does not think what random is, they just do it randomly, in that case, you'll be surprised, most of the cases, random dots are like this. That's a random dot. But when people are asked to do that, they actually just spread it out evenly, and they feel what that random is. So what you feel is random, or what you feel or what you believe something to be might not be what is actually happening. So you have to understand, in frequentist probability, we have to collect data and we have to do it mathematically. We have to give a number to that probability. A little background. Probability was discovered or invented in France in 1654. So in 1654, what happened is, 1654 in France, first of all, there was a guy whom we will call the gambler. This is the guy, the gambler. There's nothing derogatory here. Everyone calls him the gambler, so that's fine. So his actual name is Antoine Gombaud, Chevalier de Mere, and he was a gambler, and he wanted to know what happens if two people are playing a game and they suddenly stop. How do you distribute the points if they do not continue the game, and what do you do? And it's funny, this guy Antoine Gombaud, he also wrote a book called The Honest Man and Discourse on the True Honesty. But anyway, he had friends, and he asked his friend, great mathematician Blaise Pascal, and another one who in turn wrote letters to Pierre Fermat, and through 5 letters they actually created this probability and the science of probability. Of course, they were also interested themselves. It's not that it was after Antoine Gombaud said that, but they were also interested themselves. And in 1654 in France, they created this very important branch of math called probability. Another very important thing is that, since this is the frequentist probability we are talking about, the idea is that if you do this a lot of times, it will eventually come true. If you toss a coin, you might get a head or you might get a tail. But if you toss a coin many times, maybe 100, 200, 300, 400 times, you will always see that out of those 200 times, there are 100 heads and 100 tails. And this important idea called the law of large numbers, meaning if you throw a die, if you get the probability of getting a 1 is 1/6, and the probability of getting a 2 is also 1/6. The probability of getting every number is 1/6. But when you're in a random event, when you're throwing a die, it can be anything. Just because it could be that doesn't mean it happens. So you might say, why bother with it? Because if I throw a die, it could be any number, and it could be 6 and then 6, then 6, then 6, and it happens a lot of the times. But the idea of the frequentist probability is that if you do it a large number of times, and if you do it a lot of times, you will see that out of those, 1/6 of the time you get a 1, 1/6 of the time you get a 2, 1/6 of the time you get a 3, and so on and on. That means it was in 1655 that Jacob Bernoulli came up with the concept of the law of large numbers. It's also a very important concept in probability, where the idea is when you're doing it once or twice or thrice, you might not be able to see what's going on. You might not be able to predict anything, but it is with the law of large numbers that probability becomes a math, and in the long run you're able to predict patterns in probability. One thing must be mentioned, there was another guy called Cardano, perhaps the strangest man in the history of math. He actually 100 years before this came up with, he was the first guy to think of probability as a math, and he was also a mathematician, he was a gambler, he cheated a lot in gambling. He was the first guy to come up with this concept, Cardano, of probability in a book called Games of Chance. However, he didn't publish the book at that time, so we generally say that the co-founder of the concept of probability is Pascal and Fermat together. So enough of that. By the frequentist probability, where we take data and then find the probability, we call every possible outcome the sample space. So this is the sample space. Every possible outcome. In order to do that, the activity that you perform to figure out what would be a particular event, which we call an event, a particular outcome. This is the event and this is the sample space. In order to find out the probability of a particular event, you need to conduct an activity. That activity is called an experiment. So an experiment is that activity. Of course, you should be able to repeat it over and over again. That activity by which you can find the probability of something or find a specific outcome of something, we call that activity an experiment. So if you're talking about the dice game, the famous dice game, if you want to throw the dice, that's an experiment. Throwing the dice, that's an experiment. What you get when you throw the dice, on top of that, that specific outcome is the event. Maybe it's the event that you're looking for. If you're not looking for it, that's not the event you're looking for. And every possible outcome, meaning everything that can happen out of that, is called the sample space. So remember, so the best thing to know about the definition of probability is probability of an event is small n by large n. Small n is the event that you want, large n is everything else that can happen. So in an example where we throw a dice, now we toss a coin. So if you want to toss a coin, there are two outcomes. It can be head or it can be tail. So probability of getting a head is, there's only one head, and altogether there are two outcomes, 1 by 2. Probability of getting a tail is also the same, 1 by 2, which is can be written as percentage. 50%, this is also 50%. When you think about probability, the most common examples is throwing a die or tossing a coin. Now, the basic laws of probability. There are three basic laws of probability. So, three basic laws of probability. The first one is the multiplication law of probability. It says, if you want to find the probability of a particular event occurring and followed by another particular event, then this probability is nothing but the multiplication of the probabilities of the individual events. Now, in order for this to happen, the events has to be independent. That means one of the event should not be affect the outcome of another effect. An example could be tossing a coin. If you toss a coin, if you get a head or tail, it doesn't really affect if you toss the coin again. What happens the next time? It doesn't really matter at all. They are independent. So if these events are independent, so the probability of getting a head and another head, written as HH, is probability of getting a head, which is half, multiplied by probability of getting another head. So it is 1 by 4. The more you multiply, the more the probability decreases. Of course, just by simple arithmetic rule, 50% times 50%, this is if you multiply this 2, this is going to be 25%. So the more you multiply, the probability is actually decreasing. The next one is called the OR rule. The addition rule of probability, A or B occurring, is probability of A plus probability of B. Now, the OR rule says if two events that cannot occur together, it is extremely important to understand, if two events cannot occur together, it is called mutually exclusive events. Only those probabilities can be added. For example, what is the probability of getting a 2 or a 3 when you throw a die? The probability of getting a 2 is 1 by 6, or the probability of getting a 3 is also 1 by 6, because each probability is 1 by 6. If you add the 2, it would be 2 by 6. Now, it can never happen that when you throw a die once, you will get both a 2 and a 3 at the same time, just at one throw. It would never happen. It can either be a 2 or it can be a 3. So the events, they cannot occur together. They are mutually exclusive events. So the addition rule of probability says you can add up the probability. The final basic law of probability states that when you know something is absolutely, you're sure that it will not happen, we say the probability of that happening is 0, which is 0%, means 0 divided by 100 is 0. And if you know that something is absolutely going to happen, for sure, you're 100% sure it's happening, then the probability is 1. The final law says probability can only be between 0 to 1. Or if you want to express it as a percentage, probability can only be between 0% and 100%. So this final law that says that total probability that something will definitely happen is 100%, and the probability that something will not happen at all is 0%. So from here we can say that probability of something will happen plus probability that something will not happen is 1. Of course, there is nothing else. It is either going to happen or it won't happen. That means this is certain. It's either going to happen or it's not going to happen. So that is 1. From here we can write probability of something not happening is 1 minus probability of something happening. So the three basic laws of probability states that, first of all, we call it the multiplication rule of probability, where the probability of one event occurring and followed by another event occurring is probability of the first event multiplied by the probability of the second event. And we have the second law, basic law of probability, which says probability of one event occurring or another event occurring, they cannot happen together, they are mutually exclusive. Then we add up the probabilities, and the final basic law is that probability is always between 0 and 1. It can be expressed as a percentage, then 0% and 100%. So total probability is always 100%. From here we can figure out probability of something not happening is 1 minus probability of something happening. If we do an example, then it would be like this. What is the probability that it would not be a 6 when we throw a die? So it should be 1 minus probability of getting a 6. So 1 minus probability of getting a 6 is 1/6. So probability of not getting a 6 is 5 by 6. We can do the same thing by using the OR rule or addition rule of probability. If I say that we are not going to get a 6 in one throw, then we can either get a 1, or we can get a 2, or we can get a 3, or we can get a 4, or we can get a 5. So we have these possible outcomes. So we have 5 outcomes out of 6. So this is the basic laws of probability.